Welcome. In this video, we'll be discussing how to find the greatest common factor of two numbers. You can find this on page 9 in your ALEKS notes. So the first thing to note is that the word factor appears over and over in mathematics, and it has great significance. It actually can have more than one meaning. So the word factor can act both as a noun and as a verb. So let's take a look at how we're using it in this particular problem. So what we're going to look at is how do you find the factors of 6. Now the way I define factors are they're any two numbers that multiply together, in this case to be 6. So if I look at the number 6 and do what's called a factor tree, you can see that 6 breaks down into 2 times 3. Well, what that means is that 2 and 3, we say, are factors of 6. Okay, let's take a look at how to do the greatest common factor of 28 and 38. So there are several steps to the process. The first step in the process is we're going to construct factor trees for both 28 and 38. So if I construct a factor tree for 28, I have to think of two numbers and multiply together to be 28. So I'm going to choose 7 times 4. And if I look at the 7 and the 4, I need to decide if I can break either of those numbers down further. Well, the 7 I really can't break down into two smaller numbers. I can break it down to 7 times 1, but that really doesn't help me. 4, however, I can break down into two smaller numbers multiplied together to be 4. So 4 can be broken down into 2 times 2. Since the 7 couldn't be broken down, I'm going to circle it. If I look at the number 2, I can't break that down any further, so I'm going to circle that number. And same thing with this other 2. I can't break that down further, so I'm going to circle it. So what we've just discovered is that 28 is equal to 2 times 2 times 7. Now notice I'm writing the numbers in order from least to greatest. That's not necessary, but it does help our organization. So 38. If we break down 38, well, 2 times 19 multiply together to be 38. So 2 and 19 are factors of 38. And again, I cannot break 2 down further. And 19, are there two numbers that multiply together to be 19? Well, the only ones I can think of are 19 and 1. And we already said we don't want to use really 1 in a factor tree. So I'm going to leave 19 alone, can't break it down. So what that means is 38 breaks down into 2 times 19. Okay, so that's step 1 in the process, is just to break the numbers down using a factor tree. Now step 2 in the process is to multiply together their common factors. And that's going to give us our greatest common factor. So in this case, we've got 28 is equal to 2 times 2 times 7. And 38 is equal to 2 times 19. Well, if I look at what they have in common, notice that both numbers have a factor of 2 in common. So what I'm going to do is draw a little arrow from each one and write my 2. And notice how I'm only writing 1, 2. They only have 1, 2 in common. There's a 2 in each one of them, but if we look at overall, they only have 1, 2 in common. So looking at the other numbers, well, the only thing that's left, I've already used this 2 and this 2. So the only thing that's left is the 19, the 2, and the 7, and certainly there's nothing in common there. So my answer, my greatest common factor in this case, is just a single 2. Okay, let's try another example. So let's try example number 2. So example number 2 is we're supposed to find the greatest common factor. And you'll see greatest common factor abbreviated as GCF of 27 and 81. Okay, so our first step is we're going to do a factor tree for each. So 27 and 81. 27, well, 9 times 3 would certainly work. 3 I can't break down further, so I'm going to circle it. 9 can be broken down further. It can be broken down to 3 times 3. And neither of those 3's can be broken down further. So 27 is equal to 3 times 3 times 3. If we look at 81, well, I can break that down into 9 times 9. There are several ways to break down 81. This is one of them. We could have also used 27 times 3. Regardless of which pathway you use, you should get the same final prime factorization. So I'm circling what we can't break down further, and it looks to me like 81, it can be broken down to 3 times 3 times 3 times 3, 4 3's. So now if I do the second step in the process of multiplying together their common factors, well, I see that 27 and 81 definitely have a 3 in common. So I'm going to draw my arrow and put a 3 there. But I've used this 3 and this 3 now. But now I see that they definitely have another 3 in common. So I'm going to put another 3. And now I've used those two 3's up. And looking at this, I see actually that we can actually have another 3 because they've got another 3 in common. So if I drag that down, we've used this 3 and this 3 up, and now really all that's left is this 3 for 81. We've used all the numbers for 27. So what that means is our greatest common factor is going to be 3 times 3 times 3. Well, that's just 27. So my answer in this case is going to be 27. Okay, your turn. So now I want you guys to try to do number 3 and number 4. Pause the video and then restart it after you've given it a try. So for number 3, when you did the factor trees, you probably found that they didn't have anything in common. Well, what that means is automatically their greatest common factor is going to be a 1. 1 is a factor of any number. If you think about it, I can take any number times 1 and get that number back. So 1 is going to be a factor of any number. Okay, and then also try number 4. Pause the video and restart it when you're ready. Okay, so for number 4, you should have found that the greatest common factor was that they had 4 2's in common. So you should have gotten 2 times 2 times 2 times 2, or 16 for an answer.